Welcome to my YouTube channel. Today we're gonna do some calculation in hydrogen spectrum. Before we start, I would advise you subscribe to this channel to get the latest updates on other topics in your chemistry, your physics, your mathematics, and your biology. So let's get to do something. So the question is how much energy is released when an electron falls from the energy level 4 to the energy level 2, that's n equals to 4 to the n equals to 2 energy level inside an hydrogen atom. The B part of the question, what is the frequency of this photon? And the C part is calculate the wavelength in nanometer. So with this now, this is the formula we'll be using for our solving. E equal to negative R. This negative is there for because the energy is being released, so we are moving from higher energy level to a lower energy level, so that's why we have our negative R here. Bracket 1 over n final square minus 1 over n initial square. Then you cover the bracket. So here we have E equal to, the value of our Rydberg constant is 2.179 times 10 raised to power minus 18, and our bracket 1 over the n final is 2 because it's moving from n equals to 4 to n equals to 2, so the final n final is 2. So we have our square minus 1 over 4 square. We have E equal to minus 2.179 times 10 raised to power minus 18. We have 1 over 4 minus 1 over 16. Here we have minus 2.179 times 10 raised to power minus 18. So let's open this bracket. So the LCM of 4 and 6 is 4 and 16 is 16. So 4 in 16 is 4. 4 times 1 we have 4. Our minus our negative, and 16 in 16 is 1. 1 times 1 is 1. So we have negative 2.179 times 10 raised to power minus 18. Here 4 minus 1 is 3 over 16. So here we have negative 2.179 times 10 raised to power minus 18. The value of 3 over 16, if you punch that on your calculator, you have 0.1875. So we'll multiply this now, these two, we'll have our energy to be negative 4.084 times 10 raised to power minus 19 joule. Here is the energy being released. Now we'll do the B part of the question. The B part, it says what is the frequency of the photon. So we'll use this formula, E, which is our energy, equals to H, which is the Planck constant, and F, which is the frequency. So let's make F the subject of the formula. So we have F equal to E over H, H the Planck constant. So that's what we'll be using. From the part A, we've gotten our energy to be 4.084 times 10 raised to power minus 19. So divide by H, our Planck constant. The value for the Planck constant is 6.625 times 10 raised to power minus 34 joule second. So that's the value for our Planck constant. So we input it here. 6.65 times 10 raised to the power minus 34. We have our frequency to be 4.084 times 10 raised to the power minus 19 plus 34. Here is, since we are having a base 10 or 10 here, that's the exponential here. So here we bring this, and this coming up here, the negative sign will change to positive sign. So we have 6.625. So that's all we have here. Now we have, so by the time you punch your calculator, you get 0.6164 times 10 raised to power 19 minus 19 plus 34, you have 15. So now you can have your frequency as 6.164 times 10 raised to power 14 hertz. So that's your frequency. Now let's do the C part of the question. So the C part says we should find the wavelength in nanometer. So let's use this formula. Speed of light equals to f lambda. So we are looking for our lambda, which is the wavelength. So let's make the lambda the Soviet formula. Lambda equals to c over f. And of course we know our c is the speed of light. The value is 3 times 10 raised to power 8 meter per second. So that's the value of our speed of light. So now that we've make our lambda the Soviet formula, we have lambda equal to 3 times 10 raised to power 8 divided by the frequency that we got. We have 6.164 times 10 raised to power 14. That's the frequency we got, and our lambda will now be 3 divided by 6.164 multiplied by 10 raised to power 8 minus 14. So now we have our lambda to be, so when you punch your calculator, 3 divided by 6.164, you have 0.487. So we have 8 minus 14, we have that to be negative 6. So let's write this in a standard form. You have your 4.87 times 10 raised to power minus 7 meter. So we have our answer in meter first. Now we have to convert it to nanometer. So converting to nanometer, converting from meter to nanometer. 1 nanometer is equivalent to 10 raised to power negative 9 meter. So let's call the nanometer we are looking for as x nanometer, which is equivalent to what we got as our meter, which is 4.87 times 10 raised to power negative 7 meter. So what we'll just have to do now is you cross multiply and make your x the Soviet formula. So we have 1 multiplied by 4.87 times 10 raised to power minus negative 7 divided by 10 raised to power negative 9. So our x nanometer is 4.87 times 10 raised to power negative 7. So when we apply our indices here again, we have positive 9. So this is the same as 4.87 multiplied by 10 raised to the power of 2 nanometer. If you like, you can leave your answer here, and if you like, you can go further and say 87 nanometer. This positive 2 here has cleared it, so your points move here for 1 and then here for 2, so we have cleared out the point here. Thanks for watching. Please subscribe to this channel and share the video, invite your friends, and come for biology class, physics class, mathematics class, and more of chemistry topics. Thank you.